Hi. Let me figure out how to best do the mic. Okay. Hi, I'm Axel. I'm loud on the internet. Oh my God. Can we turn this down? It is annoying to hear myself with a 100 millisecond delay. Yeah. Okay. Yeah, let's try. It's fine. Let's try. Hi, I'm Axel. I'm not on the internet. So some of you might have heard of me if you are online in the Go space, like on GitHub or the mailing list or Reddit. I tend to butt into any discussion that is kind of interesting. Um, and so a lot of you might have heard my name. And that's kind of what I do. And so I have a lot of context about how the Go ecosystem works and like why Go is the way it is. And I'm trying to teach you about this context. I'm sorry, the delay is really killing me. Um, yeah, so the title of the talk is So You Want to End Variates to Go, right? So maybe you come from a strongly typed language like Haskell and you miss its algebraic data types, right? Or you come from Rust, which has enums, and you miss those, right? Or Java or C Sharp, which actually don't have these, but C does. So maybe you know them from C, or you're a scripting language kind of guy, right? So maybe you come from TypeScript or Python, even those have those. So the point is, basically every quote unquote modern programming language seems to have this like ability to say here's a type that is one of a list of other types, but Go doesn't. And this is a useful feature. So maybe you think like, I want to propose adding this to Go. So you go to the issue tracker and you actually find that there is already a proposal for this, which makes you very happy. And then you notice that it's 8 years old and has 430 comments. And you do not want to read 430 comments. And so what I'm trying to do is I will try to summarize these comments for you, this discussion for you, right? Okay, so let's first talk a little bit about why this is a useful feature. What is the thing people actually want from it, right? And so the first thing that might be a bit obvious is they want a closed list, right? So Go already has types that are sort of unions, which are interfaces, but interfaces are open, right? Every interface has a functionally infinite list of types implementing it. And so people want to say, no, no, I want a shape type, and the shape type is exactly one of these three and nothing else, right? And just as a note, in this talk, I will occasionally make up ghost syntax, like the enum here. Uh, I don't care about syntax in this talk because, in my opinion, syntax is actually easy, right? The hard part is coming up with the semantics. What do we want from them? How do we want them to work? And once we have that, figuring out a good syntax is usually not too hard, right? So don't get hung up on syntax. Just wing it. Yes, the other thing most people want from like variants is they want exhaustive switch checks, right? That is the other thing people don't like about doing like enums with interfaces is if you forget a case, the compiler has no way to let you know, right? And so people want that like in this case, we forgot the rectangle case. They want the compiler to tell you, nope, you forgot a case. Please try again. Um, and then the thing that people want is something I would call well-defined state, right? One of the most popular reasons for people to want variants is they want to have a generic result type because they are annoyed by Go's error handling, right? And they want to have the assurance that this result type can be either a t, right, a value, or an error. It can never be neither, it can never be both, right? Because they are very annoyed at the fact that if you have multiple return values, the error might or might not be null, and the value might or might not be useful. You might forget things, you always have to check. They want the compiler to automate this for them, which also makes sense, I guess. Yeah, so once, like, now that we have understand a little bit what people are looking for, let's look at the design space, right? What are the kinds of questions we have to answer when it comes to writing a proposal for this. And the first most important decision we have to make is the one between union types and sum types. And a lot of people use these words kind of interchangeably, but they are actually very different. And that's kind of the main point I'm trying to make. So union types are based on mathematical set unions, which we use this like U cup operator. And a union is just the union contains every element that it is one of the input sets, right? So, for example, in this case, we have one set is 1, 2, 3, 4, 5, and in the other we have 2, 4, 6, 8. And so the union of them is 1, 2, 3, 4, 5, 6, 8. I think everyone kind of understands how unions work. Some types work similarly, but they keep track which of the input cases this comes from, right? So you can think about that as kind of the individual terms in the sum to have a color, and then the elements in the sum retain this color. So for example, in this case, we have 2 twos, a red and a blue 2, and 2 fours, a red and a blue 4. And if we take something out of this sum, we can always say which color it originally has, right? Or to make it a little bit more concrete, from the examples I mentioned earlier, TypeScript has unions, right? And so you can define my union, which is a number or a string, and then we can assign 42 a number to it, and that's fine. Or we can assign a string, and that is fine, right? And that's how unions work. Rust, on the other hand, has sum types. And one difference here is if you look at the lines at the bottom, that we can no longer just say x equals 42. We have to say x equals my sum : int 42. And the my sum : int, that is the color, quote unquote. And to make clear a little bit more why this matters, let's pretend Go had unions, right? What would happen if to this union we add a duration? Right? If we now assign 42 to x, well, 42 is assignable both to int and to time.duration, because time.duration is just an int64 under the hood, right? With sums, this is not a problem, because with sums, we explicitly say, no, we want the int color of 42, right? And so sometimes some types actually do something different, and that is reflected in the syntax. Yes. The next question we need to answer is how we unpack them. And usually we use some sort of switch statement. In Go, you would probably choose to use a type switch. And when you decide how to do that, there are a couple questions that you have to answer. For example, do you want to allow overlapping cases, right? In Go, you can have types that are elements of multiple cases. For example, of multiple types. For example, os.file is obviously a member of os.file, but it's also a member of io.reader and io.writer. And so the question is, if you have overlapping cases, if you allow that, what do you do if a type is in more than one case, right? Which of the cases do you choose? This is not a thing that happens with sums, because in sums, every value has a specific color, right? They can only ever be in one. You also have to decide on exhaustiveness checks. And again, with sums, this is pretty easy, right? Because you just have to check, does the switch or whatever contain every color exactly once? But with unions, this is more complicated, again, because of these overlapping cases. And in fact, you do have to kind of be careful, because if you do this wrong, it might end up that exhaustiveness checks are NP complete. And I will not explain why and how, but you have to be careful because of this overlapping problem. You can also instead just say, well, we will just force a default case. Every switch over a union has to have a default case. That's another thing you could or could not do. It has certain advantages. And you also have to wonder out, do you want to support pattern matching? And I will show Rust to demonstrate what pattern matching does. If we want a Rust function that tells us whether a shape is degenerate, so if it has area 0, We can write this as a match statement that just says, well, a circle with radius 0 is degenerate, a square with side length 0 is degenerate, and then like a rectangle with width 0 and any height is degenerate, and a rectangle with any width and 0 height is degenerate, uh, and anything else isn't. And so you can imagine like pattern matching works like you both list the quote unquote color, but you can also pair it with like if else statements for the values that are inside. And you can do that in a very convenient syntax. And this is also something a lot of people who like Rust are a big fan of. And so maybe you want to support that. Right. Then there is a very Go specific thing, which is gradual code repair. There's a principle in Go that APIs should be interoperable when moved from one package to another. And one package to another can mean a major version update of your module, for example. That is for Go just moving from one package to another. And to explain what I mean by this, let's look at a concrete example. The context package didn't used to be in the standard library. It used to be in an experimental package in XNet context. And when we introduced the standard library package, we redefined the context type of XNet to be a type alias to the standard library context. And in fact, that is why type aliases exist in Go, to enable this kind of move. And so imagine a situation where you have a program that imports two packages, package A and package B, and package A and package B still use the experimental version of context. And now package A releases a new version, and this new version moves over to the standard library context, right? And now it turns out like the package B people are on vacation or something, you cannot reach them. They are too lazy to update their stuff, so they continue to use the net context version. And now you want to update your package A version. If the context type of the standard library context package and the XNet context package were not interoperable, if they weren't the same type, if you were to pass types from one package to the other that involve context, that would break your code. And we never want that, right? We want to be able to do any API migration package by package, hence gradual code repair, right? The gradual refers to this package by package concept. And we want to do that because we tend to use Go in big software ecosystems. For example, in open source, where you just can't rely on being able to do a atomic commit over your entire code base, including all dependencies, right? And the reason I mention gradual code repair is because exhaustive switch shaking breaks gradual repair, right? If you have a sum type or union type that does an exhaustive switch check, you will never be able to add new cases to this union, even in a new major version, without people then being forced to wait with their updates because like there's some incompatibility. And so this is something you need to take into account. This is something that is often misunderstood. Like when I point this out, a lot of people say, well, but the fact that it breaks if you add a case is a feature, not a bug. But that's misunderstanding the point. The point is not that it breaks. The point is that you cannot migrate step by step to fix that breakage, right? Right. And then the other very Go specific thing you have to worry about are zero values. In Go, every type needs a zero value. And that zero value really should be represented by 0 bytes. So you cannot just define a default value of 42 or whatever. You have to actually use 0 bytes. And that basically leaves you with two strategies. Either you designate like a default term in your variant, and then you say the zero value of your variant is the zero value of that default term. And you can do that either using like an explicit marker by saying this is the default type, or you can do it like implied by order by saying, well, it's always the first type in the list, right? And the other strategy is you use a sentinel for no value. This is what normal interfaces do, right? There is an interface null, that actually says this interface has no value, no type, nothing. And it could also contain like a pointer null, but that is not an interface null, right? And so you can do the same thing with your variant by saying, well, there is a variant nil or whatever. You can call it 0 or whatever you want. So now we hopefully kind of understand what the questions are we need to ask. Now look at a concrete way to integrate variants in Go. And specifically, ever since generics, we actually do have something that looks suspiciously like a union type. So you can write interfaces that have multiple types separated by pipes, and these are called union elements, but you can only use them as constraints on generic functions. You cannot use them as types, right? You will get an error if you try to do this in this G. So the easiest way we could add variants to Go would be to say, well, we will just remove that restriction, and the unpacking we do using the same old type switch that we already know. And then basically everything flows from these decisions, and we see where we land. And there is a proposal filed by Ian Lance-Taylor. I put the number here. So the first consequence of when we do that has to do with nested unions. So right now it makes sense to have a signed interface that lists all the signed integer types, and an unsigned interface that lists all the unsigned integer types, because like maybe you have a generic function that only works on unsigned numbers or whatever. And then it makes sense to also have an integer interface that just says it's either signed or unsigned for functions that work on either, right? And the problem is that as a union type, the integer interface has a signed case and an unsigned case, right? But you can write the same interface by just writing out all the terms individually, and now there is no longer a signed or an unsigned case, right? Like these are the same interfaces, and we want them to continue to be the same interfaces because it would be very confusing if they suddenly stop being the same interface. But that means we kind of can't have nested unions. You can never have a union type as a case in your union because it will always just get flattened away, right? And that is kind of unfortunate. The second thing is about interfaces. So remember how I said that one thing, like basically these thing people want from variants is this generic result type. Turns out you can't do that, right? If you try to write this type, the compiler will tell you cannot use an error in union. Error contains methods. Because Go forbids you from putting an interface that contains methods into a union element. And the reason for that is complicated. And if you're interested in the details, I gave a talk and an accompanying blog post a couple years ago. So you can just put this title into your favorite search engine and you will find it. But it is not a random restraint. It is something we can't really fix, which also means you cannot have interfaces in unions, right? And so basically the main thing people want unions for or variants for doesn't work. Fine. The next thing is, what do we do about the 0 value? Well, the first thing is we can right now write a union interface, and that is valid, and it contains no explicit marker for a default type. So we cannot choose the mark a default type thing because we wouldn't have one for legacy things. But also the union elements are commutative, so we can flip the order and it's again the same interface. So we also can't rely on order, right? Because it is not well defined what the first term in the union is if you can the union in any order you want. So we really must make the 0 value null. We need to add a designated sentinel for no value. We pretty much have no choice. And now remember how I said that people want well-defined state, right? They want an assurance that a result T, even if we could write them, there are hacks to do it, right? They want it to be either a value or an error, never neither and never both. Well, now we have determined that we cannot exclude the neither case. Any union can always have no value and people have to deal with that, which will probably make people unhappy. And then for type switches, basically we just want to stay consistent with the rest of the language. So we do not false defaults. We do not do exhaustive checks. We do allow overlapping cases. Our conflict resolution is we choose the first case that matches in source order. And this is not like this is not news. This is just how type switches work today. But it would be confusing if type switches would work differently for unions than for regular interfaces, which is why, again, we are kind of stuck with this. And so, like, basically at this point, we notice that, yes, we can do this, and then we will have union types. But most of the advantages that people want from union types or from variants are actually gone, right? Basically, the only thing is that's left is that it's a closed list, that it's no longer an open list, which is a real advantage, but it is a comparatively small advantage compared to all the things people want from it, right? So what's the alternative? The alternative is we just add a new thing. And I hope I have convinced you that if we add a new thing, that should be a proper sum type, because sum types are better. Um, but even if you choose a union type, you will have the same problem, right? Um, this is actually relatively easy to design, right? I do not go into a detailed design because you can pretty much just do whatever other languages do, and that is going to be fine. I want to point out in particular this unions as sigma types proposal, because in my opinion, it is very well written. It started as an April Fool's joke, and if you look at this proposal, that is very funny because it is long and very well thought out. Um, I don't think this is what we would do if we added sums to Go, but it is something I really like. But if you do this either way, you will end up with having two separate concepts of closed lists of types in the list in Go, and both have different uses, different syntaxes, different restrictions on how you can use this. And that is probably very confusing to teach to people, right? Even today, people are confused by the fact that you cannot use union elements in types. That is not going to get better if we also throw some types in, right? Um, is at least that's where the discussion is at, right? So that's kind of the conclusion. That is if you open this issue, the context that you need to know is there are at this point essentially three realistic options. One is we do the existing union elements and make them into types. That is probably make a lot of people very angry and is generally considered a bad idea. Sorry, I um, it's relatively low benefit, and all the people who really advocate for some types will be really pissed off if you do that. But maybe we do that. That's fine. Um, or you kind of add proper sum types as a separate thing, but it's likely too redundant. Or you do nothing. You just say Go doesn't have variance. And because Go is pretty conservative, given that neither of the first two options is clearly good, we always default to do nothing, right? The reason we don't have variants is not because we don't think they are useful or we don't know how. It's because all the options we see, like none of them could reach consensus. Everything would make people unhappy, like one decent chunk of the community unhappy. And in these cases, we will just not do anything and wait. And maybe someone will magically figure something out, or we will never get variants, or we will just decide to eat the downsides at some point, right? Like perhaps at some point, someone will convince the Go team that the benefit is large enough to justify the cost, then we might still get them. But yes, that's basically everything. So thanks for your attention and enjoy the next talk. Questions?